Question number 10. Yeah. June and November papers are the same, ne? But don't let anyone lie to you and say prelims are the same as June and finals. They are not. Prelims whip if you didn't study. So it says here, two circles touch each other internally. So they touch each other, and then it says B, yeah, they touch internally at B. And then it says O is the center of the bigger circle. Okay, so it means the diameter of the smaller circle is the radius of the big one. And then it says here, yeah, it's O is the center of the bigger circle, lies on the circumference of the smaller circle. Okay, fine. FBG. Where's FBG? FBG, where are you? FBG is a common tangent. Whoever set this paper name was angry. I don't even want to lie, they were angry. Then it says AB and BC are chords. AB and BC are chords of the bigger circle. Yes, they are. And then they say it here, and intersect the smaller circle at D. And then at E respectively. So this sketch looks a bit cluttered, but it's fine. AHG forms a straight line. Yes. Chords OD, where's OD? There's a chord OD there. DE, and then OB, they're just chords of the smaller circle. And then they gave us a ratio. AH and AG is 1 to 2. So that kind of looks like it's going to help us, especially how we have a parallel line here. Another line that's parallel there. So already with this triangle here, we can see we're going to be doing some proportionality theorem shandies here. Definitely, like you can already see, yeah, it's going to go down there. It's going to go down. So for 1 mark, they said, why give a reason why B4 is equal to HCB. Where is B4? B4 is here. HCB is here. Wow, why do they have to be so extra? So they're talking about B4, which is here. And then the angle, the other angle, HCB is over here. Wow. Well, I'm thinking of the 10 chord theorem, but at the same time, this is here, but it's not the 10 chord theorem here. These are alternating angles, you see. Yeah, just say alternating angles. Alternating angles. It's not the 10 chord theorem. If you say 10 chord theorem, you're wrong, because it's a point on one side, one point of the big circle, one point of the big circle, but then this one ends up in the small circle. So don't make the mistake of saying 10 chord theorem here, because nope. These 3 points would have needed to be in one full circle. They're just equal because they're alternating angles. They say give a reason why B4 is equal to D4. Where is B4 now? B4 and D4. This one now is because of the 10 chord theorem, because you see in this small triangle here, you already have the 10 chord theorem. Lucker. So 10 chord theorem. 10 chord theorem. For 3 marks, they're asking us to prove similarity. DBE. Where is DBE? Department of Basic Education. Where is it? I don't know. Somewhere in Gauteng, maybe. Is it? I don't know. Maybe it's in Cape Town. Okay, KZN. But I think it's in Gauteng. Their HQ. Never mind. Let's see. DBE. We should prove that DBE is similar to DBC. Where is DBC? DBC. Oh, the big one and the tiny one there. Come on now. So with these kinds of questions, they're already giving you hints. You should just prove that this part is equal to that part, this part equal to that part, and this part equal to that part. So just take 2 pairs that are the easiest to prove. And then the third ones, you can just say they're equal because of interior angles of a triangle. So the easiest one that we have is the B4 here equal to the, no. The angle, this portion of C is equal to this portion of this triangle here. So the C is equal to the D there. So wait, no. What? I feel like I used different triangles now. Did I? No. I I feel like I should just bring my sketch down there, because this whole thing of being up and down is not good. I'm not loving it at all. There's no McDonald's here. So anyways, let's see. Paste. Crop. And then we need to make it smaller, obviously. Otherwise, if you don't know where, if you don't get an idea as to why I was singing that, you're not a Trevor Noah fan, you. You're not a Trevor Noah fan, you. Who does not know that one? But anyways, it doesn't matter. What do we have? Let me just see these two triangles. DBE. So there's like D, B, and E. And then the other triangle, let's use a yellow. It's like DBC. So it's like D, B, C. So we proved that this angle is equal to that one. No. I gotta use different dots now. Let's use a, what you may call, let's use a green. So we proved that this angle here, right, was equal to that one. And then we also proved that this angle here was equal to that one. That is quite interesting. Yeah, because it's the D here for the small triangle. And it is the C for the other one. Something does not look right here at all. Like, I am not feeling this question. Like, I was, but now I'm like, wait, what? Like, what? Because it's like, nah, fam. Nah, fam. No. But anyways, the B is a common angle, so we might as well start there. It doesn't look like these were written out in a way that can help us. Yeah, it looks like they actually conned us there. Don't wanna lie, they conned us big time. But anyways, it's so sad, because it's like, but why would you do that? Like, why would you do that? Yeah, these people in this paper name, I don't wanna lie. Yeah, in this paper they were evil. They were really evil, because the way they wrote it out here, these don't align at all. So it's like and the thing is, they always align, you know. It's only in this question where they really don't align. So it's like, this is scary. But anyways, we have a common angle here, which is like angle B, right? So DBC. So in these triangles, right, we can say here DBC is equal to DBC. The reason is common angle. Perfect. Now here we can say D4 is equal to C. D4 is equal to C. Proven. We proved that they're equal to each other. Like we did. We literally did. You see. So they are both equal to B4. So here you can then say the last pair of angles, right? Which is technically going to be E2 there. And E2 and the whole of D here. Yeah, which is CDB. CDB. These are equal because of sum of interior angles of a triangle. So normally these match, meaning D is equal to D, this is equal to this is equal to this. Normally they match, but in this question they really don't. Hey, so yeah, don't fall for that trap. So here we can say, therefore, the two triangles are what you call similar. But then you might also just want to write your answer here in a way that it shows that in a way that aligns with each other. Meaning, if you're going to call this triangle DBE, right? DBE. The other one, you might as well call it CBD. You see, because the D here is equal to the C for the other one. The B here is equal for both triangles. And then here it's C, B, and then D. Now Vanessa has entered the meeting room. Oopsie. These are similar because angle. All angles are equal to each other, you see. And then that will be that. You are good to go. So with all that being said, let's see, we have 10.2.2 here, 10.2.3, 10.2.4, 10.3 here. Oh, yeah, we have quite a lot. But anyways, it is what it is. It is what it is. It is what it is.